To determine if we can install any equipment in a hazardous location, we need to ask 4 simple questions. The first question: what is the hazardous location? And what are the key parameters of the hazardous location? Different hazardous locations will have different requirements. Those requirements are what we need to know before we can begin. The next question is, how can I tell if my equipment is approved for use in a Canadian installation? There are a variety of marks with subtle nuances that tell us if a product is approved. Learning about these product markings will help us make the proper assessment. The third question is, what do the equipment product markings mean? And how do I interpret them? Electrical products may be marked with zone markings or division markings, depending on the products used to certify the product. Since you may install both types of products in a hazardous location, it's best to know how to interpret both types of markings. And finally, once we have determined what the product markings mean, we need to determine if the product is safe to install in the intended hazardous location. We do this by referencing the installation rules in the Canadian Electrical Code. To help with this task, we've created the Hazloc cheat sheet. It helps summarizes the Canadian Electrical Code requirements concerning hazardous locations. You can download the cheat sheet from the following link. Keep it handy, as we will be using the cheat sheet as we progress through the course. Keep it with you when you need to specify or install equipment items in a hazardous location. With a bit of practice, you'll be able to handle any Hazloc product assessment situation that may arise. So let's start by defining what a hazardous location is, defined in the Canadian Electrical Code. Any premise, buildings, or part thereof in which there exists the hazard of fire or explosion due to flammable gases and liquids, combustible dusts or flyings, ignitable fibers and materials. An owner is required by code to define the classified areas within their operations. Facilities may be classified using the zone system or the division system of classification. The rules that apply to the zone system are defined in Section 18 of the Canadian Electrical Code. Appendix J applies to facilities using the division system of classification. Locations where an explosive atmosphere may exist will be identified by a hazardous area classification design drawing or document. The drawing legend will define the system of classification used and indicate the degree and extent of the classified areas. It will also determine the group classification and auto-ignition temperature of the flammable materials handled within the facility. In this example, the legend indicates the facility was classified using the zone system of classification. A Group 2A designation with an auto-ignition temperature of 600 degrees Celsius is prescribed for the flammable materials. Locations classified using the zone system for explosive gas atmospheres will be divided into Zone 0, Zone 1, and Zone 2. Locations with combustible dust hazards will be classified as Zone 20, 21, and 22. The criteria for zone classification is defined in Section 18 of the Canadian Electrical Code. A Zone 0 or Zone 20 location indicates a very high level of risk, as there is expected to be a continuous explosive atmosphere. Locations classified as Zone 1 or Zone 21 indicate that there is likely to be an explosive atmosphere in normal operation. A Zone 2 or Zone 22 location indicates that an explosion hazard is not likely to exist, and, if it does, will exist for a short time only. Locations where the explosion risk is deemed negligible are designated non-hazardous. Locations using division methods will have 2 levels of classification. The group classification is also different, and a temperature code will often define the auto-ignition temperature instead of being defined in degrees Celsius. The division system divides classified locations into 2 levels of risk. A Class 1, Division 1 location is where an explosive gas atmosphere will be present continuously, intermittently, or periodically during regular operation. The definition is roughly equivalent to the blending of Zone 0 and Zone 1. A Class 1 Division 2 location is one where an explosive gas atmosphere is not likely to exist in regular operation and, if it does, will only exist for a short time. The definition is identical to a Zone 2 location, implying the risk is equivalent. The same is true for Class 2 location definitions. Let's look a little bit closer at the group classification, an essential parameter for specifying explosion-protected products. In zone-classified facilities, the hazard will be defined as Group 1 for underground mine applications, and Group 2 for surface facilities. Surface locations will be further classified into Group 2A, where materials such as natural gas, propane, and similar hydrocarbon products are used. Group 2B will apply to H2S, ethylene, and similar products. Group 2B plus H2 is for hydrogen, and Group 2C is for acetylene applications. For combustible dust hazards, the group classification refers to particle size. Group 3A applies to ignitable fibers. Group 3C applies to combustible metal dust. And Group 3B covers all other combustible dust applications. The group classification under the division system differs from the zone system in how they're labeled. The division system incorporates 4 gas groups. Group A is for acetylene gas applications only. Group B is for hydrogen or similar products. Group C is for H2S and ethylene equivalent atmospheres. And Group D is for hydrocarbons and similar products. Combustible dust hazards are categorized as Group E for combustible metal dust, F for carbon black, coal, or coke dust, and Group G for flour, starch, or grain dust. Let's compare the group classifications between the zone and division system of classification. This is necessary if we install division-marked equipment in a zone-classified facility or zone-marked equipment in a division-classified facility. Using the table that we see horizontally, the 2 group classification systems are equivalent. Group D under the division system is equivalent to Group 2A under the zone system, and vice versa. Similarly, a Group 2B plus H2 group classification is equivalent to a division group B, C, or D. Vertically, the groups also have a hierarchy. Group 2C is the most stringent group of classification under the zone system, and a product marked 2C may be used in all group classifications. A division product marked Group D may only be used in classified areas marked Group D or 2A. Notice that under the division system, all applicable group levels are indicated. The zone system does not do this, as there is a hierarchy in the group classification. For combustible dust applications, comparing the 2 systems is a little bit different, in that you must incorporate the class definitions to make the comparison. Here you can see that a Zone Group 3A classification is equivalent to a Division Class 3 classification for ignitable fibers. A Group 3B encompasses both Class 2 groups F and G. A Zone Group 3C is equivalent to a Division Class 2 Group E for combustible metal dusts. The other key parameter that we need to know is the auto-ignition temperature of the flammable materials that are handled within the classified area. This is important as we want to ensure that the surface operating temperature of the electrical equipment does not exceed the temperature where the flammable materials will self-ignite. The auto-ignition temperature of flammable material is determined in a laboratory environment using an oven and test vessel. AIT values for a select list of flammable materials are provided in Appendix B of the Canadian Electrical Code. When a temperature code is indicated on a drawing, the actual auto-ignition temperature must be cross-referenced with the applicable temperature code as shown. For example, if you determined a flammable material to have an auto-ignition temperature of 230 degrees Celsius, the hazardous area classification drawing would be marked T2C. The EngWorks cheat sheet incorporates a temperature code table to help you interpret all of these temperature codes. So now that we know a bit about zone and division classified areas, let's review what information we need to make an assessment. The first step is to determine what classification system is used. This will tell us whether Section 18 or Appendix J18 applies within the Canadian Electrical Code. This will be evident from the drawing legend. Next, we need to determine the zone or division where the product will be installed. The hazardous area classification documentation will provide this information. We need to know the group classification and the auto-ignition temperature of the classified location where our product will be installed. Be aware that the AIT may be defined by a temperature code. It is also essential to verify that the hazardous area classification documentation was issued under Professional Engineering Seal. Please reference Appendix L of the Canadian Electrical Code for more information on hazardous area classification design and the documentation requirements. The next question you need to ask is my product approved? All electrical products intended to be installed using the Canadian Electrical Code must be approved. A product is approved if it has been certified by an accredited certification or inspection body that it meets the safety requirements of a recognized Canadian product standard. A certification mark is evidence of a product's approval. Let's look at a few examples. The CSA mark by itself implies Canadian approval. Other certification bodies will indicate a Canadian approval by placing a small c adjacent to their certification mark. This also applies to products certified to U.S. product standards. They will have a small US adjacent to the certification mark. Many products will be certified to both Canadian and U.S. standards and carry both a C and US adjacent to the mark. For more information on certification marks acceptable in your province, see the website links below. On occasion, you may also encounter a field evaluation or special inspection label on equipment items. This evaluation program permits an inspection agency to approve and allow equipment to be installed using the Canadian Electrical Code. A reference can quickly identify a field evaluation to SPE 1000 on the label, which is the standard used for evaluating products under this program. Be aware that an SPE 1000 field evaluation does not apply to products intended for use in hazardous locations. For hazardous location products, a unit verification or field certification is required. This will be indicated by the label applied to the equipment as shown. The product will be assessed using the new CSA C22.2600079-46 standard for equipment assemblies in hazardous locations. The product will be identified with hazardous location markings that will help you make an assessment. Hazardous location products may be marked with division or zone markings. The difference depends on what the product standards were used to approve the product by the certification agency. As you can see on your screens, the two marking systems are very different. The zone-based marking system identifies the method of explosion protection incorporated into the product. The division-based marking system identifies the end classification where the equipment may be installed. In both cases, the markings must be interpreted to determine if a product is suitable for installation in the defined classification. This is an example of a division-marked product. This is an example of a zone-marked product. This product incorporates both zone and division markings. Let's look a little closer at this example. The product incorporates both CSA and FM certification marks, as well as zone and division Hazloc markings. The challenge is to determine what markings apply to a Canadian installation. As we discussed earlier, the priority is to check for a Canadian certification mark. In this case, the CSA mark indicates Canadian approval. The FM applies to U.S. product standards. Notice the certification number below the CSA mark. This is the CSA certification file for the product. The X beside the product indicates there are special considerations concerning installing this product. If you wanted to confirm if a product is certified or the special conditions that apply, you could verify the details of the CSA product listing by searching the certification file number on the CSA product listing directory website. We cover how to do this in our Hazardous Location Fundamentals course. The next challenge is to determine what hazardous location product markings apply. The applicable zone markings for a Canadian certification are highlighted in yellow. The markings are identical to the IEC markings used elsewhere in the world. The applicable U.S. zone markings are highlighted in red. U.S. zone product markings are unique and will always be preceded by the class and zone the product is suitable for, as well as an A. The division markings highlighted in blue are identical for both Canadian and U.S. jurisdictions. The ambient temperature range indicated applies to explosion protection. It does not imply that the product will operate within this temperature range. It suggests the product will provide explosion protection within its temperature range. Products that are certified to division product standards will have division markings. This is the basic template. A division-marked product will indicate the class, division, the group classification, and have a temperature code where the product can be installed. The class indicates what type of explosion hazard the product is suitable for. Class 1 is for flammable gas explosion hazards. Class 2 is for combustible dust hazards, and Class 3 for ignitable fibers. A product marked Division 1 will be suitable for both Division 1 and Division 2. The group classifications will always be marked on a division product. For example, a product that was marked Group C and D indicates that the product is suitable for gas groups C and D. A product marked EFG indicates the product is suitable for all combustible dust groups. The product temperature codes indicate the maximum surface operating temperatures for the device. For a safe installation, the maximum surface operating temperature corresponding to the temperature code that's defined in the table cannot exceed the auto-ignition temperature defined for the classified area where the equipment will be installed. Manufacturers will often abbreviate the markings on division products. In this example, class is abbreviated to CL with only the Roman numeral I and double I. This indicates the product is suitable for both Class 1 and Class 2 applications. On some products, the class marking will be highly abbreviated. You may need to interpret the class marking on some products. On some products, the division marking may be omitted. When this occurs, it indicates the product is suitable for both Division 1 and Division 2. The group markings will always appear on a division-marked product. The markings will indicate all groups the product is suitable for. The temperature code will often be omitted from division-marked products. When this occurs, the default maximum surface operating temperature for the product is 100 degrees Celsius. 100 degrees Celsius corresponds to a T5 temperature code. Zone products take on a different approach to marking. Instead of indicating what location a product is suitable for, zone markings identify the explosion protection technology that's integrated into the product. A zone marking will be preceded by the letters EX, implying that the product incorporates explosion protection. The type of explosion protection incorporated into the product will then be identified by one or more alphanumeric characters following the EX. Our Hazardous Locations Fundamental course covers the various types of protection in detail and how they provide explosion safety. Zone product markings will always indicate a group classification and temperature code on the product. On some products, the temperature code will be replaced by a surface operating temperature value preceded by a T. Newer zone-marked products will also incorporate an EPL, or Equipment Protection Level marking. The EPL marking helps to determine what zone classification a product may be suitable for. The EPL marking on zone products is a recent addition. It helps to identify what zone classification a product is suitable for. An EPL mark consists of two letters. The first indicating the explosion hazard the product is suitable for. The second letter defines the level of explosion protection provided by the product. Products marked GA are suitable for Zone 0. Products marked GB are suitable for Zone 1. And products marked GC are suitable for Zone 2. Products marked DA are suitable for Zone 20, DB for Zone 21, and DC is for Zone 22 applications. Now that we've determined what markings apply, we need to determine if the product is suitable for installation in the classified area. To do this, we reference the relevant sections of the Canadian Electrical Code. For zone classified facilities, Section 18 applies. For division classified facilities, Appendix J18 will apply. Both sections reference Table 18 in the code. Table 18 indicates what type of protection is suitable for installation in a defined classified area. Table 18 is new to the Canadian Electrical Code. The left column indicates the area classification where the product will be installed. The right column defines the type and the level of protection suitable for use in that classified area. The type and level of protection must then be compared to the Hazloc markings on the product. When the product you're installing is approved and marked with the type and level of protection defined in Table 18 and the group markings and temperature code meets the requirement of the end-use classification, the product is considered code compliant and safe for installation. To make things easier, we've incorporated all the information you need to make a product assessment in our Hazloc cheat sheet. It breaks down the markings on zone and division certified equipment and provides some useful information for cross-referencing group classifications and interpreting temperature codes. There is a lot of information on our Hazloc cheat sheet. We can't cover it all in our Supermini course. We do so in detail in our online Hazardous Locations Fundamental course. Congratulations! You've completed the EngWorks Supermini course. Thank you for taking time out of your day to learn about hazardous locations. Remember, explosion safety is everyone's responsibility. If you liked our Supermini course, let us know. Our mission is to educate and engage. Your feedback comments are welcome. Thank you for taking time out of your day to learn about hazardous locations. Remember, explosion safety is everyone's responsibility. And thank you again for participating in the EngWorks Supermini course.